So here we want to try to get a grasp on what functions are. And the easiest way to do that is to look at some examples of things. A function is anything where we have two groups. You see here some names and some numbers, and there's a relationship between the two groups. At the top you see the number of representatives by state is what we want to use as our function. Well, it's decided by what state it is. For example, Alaska is 1, Arkansas has 4, Texas has 36, Florida has 27, Kansas has 4. A few interesting things about this. First off, notice that we're taking the group of things on the left, and each one of those produces one of the things on the right. So the one on the right side, the number, is determined by what's on the left. Now this is usually represented in mathematics in the thing that we call set notation. So here you see the little squiggly lines that mean the sets, and inside that we have groups of things in parentheses. Notice that here we have Alaska on the left and the number 1 on the right in the parentheses. This is called an ordered pair. The word Alaska, the state Alaska, gives an answer of 1, and that's the number of representatives of that state. And you can see the same thing is true. Each one of these is a state with a number that goes along with that state that describes the number of representatives. Here's another relationship that is described by the arrows. Notice it says Letitia gives an answer of 8. Someone asks you, okay, what's Letitia's number? It's 8. What if someone asks, what's Tony's number? Well, look at the list. There's not a unique answer for Tony. The idea of a function is there ought to be a unique answer. We like for things in our world to have a specific answer. And so that's what functions are. In math, we just have a little bit more specific way of defining that idea. So here we have a situation where we've got a job making $10 an hour. 40 hours should give 10 times 40 or $400. 30 hours should give $300. So the number of hours worked determines the salary. We can write this much like we did earlier. We can take this group of numbers and this group of numbers and line them up and say, okay, this is what we've just said. The domain is the word that means the numbers that determine the answers. The answers are called the range. Those are just words that we use in math. So here's the same numbers jumbled up a little bit, but the idea is each number in the domain gives one and only one answer in the range. Now that's the fancy definition of a function if you needed such a thing. We need to recognize though when we've got a function. Here's another visual representation for a function. So we're looking down through the domain numbers and asking, do any of those give more than one answer? And the question or the answer to that is no, they don't. They all give one unique answer, so it is a function. Is this one a function? Well, I'm looking at 33 and it gives an answer of 15, and I'm looking at 42 which also gives an answer of 15, but that is beside the point. The question is, how many answers does 33 give? And the answer is one and only one answer. 42 gives one and only one answer. Every number gives one and only one answer. Here is a situation, however, where the number 25 gives what? 2 answers. Here's the same situation we looked at earlier. Here it is in set notation. We use again the ordered pairs. 10, 100 means 100 is the answer for 10. And so on. Here's a question that asks, is this a function? Well, I'm looking at the first pair, and a 1 gives a 15. Do I see any other pair where 1 gives anything other than a 15? That is a function. Here's another one. 1 gives 5, 2 gives 5, 3 gives 11, 4 gives 8, 5 gives... Does any number on the left have a different answer? No, it doesn't. That's a function. Here's a set of numbers. Notice in the first pair, 1 gives an answer of 5, and in the last pair, 1 gives an answer of 7. You cannot have two different answers for the same number and be a function. Well, we really need to know, what does this look like in graphical form? So here is a graph of a relationship, and we want to know, is it a function? Now, if it's a function, then any number we choose along the x-axis has to give one and only one answer. That means it must intersect the graph in one and only one spot. This is referred to in graphs as the vertical line test for functions. Does a vertical line, wherever it's put on that function, touch in one spot? Yes, it does. Here's another one. Does a vertical line touch in only one spot? Well, you can already see that line touches the graph in two spots. That is not a function. Here's one. Is that a function? Well, that line touches in one spot. Anywhere we put that vertical line, if it touches in one spot, that's a function. Is that a function? Already we can see that it is not. Here's a computation involving the variable x. What do we get when x is a 3? We plug in a 3, see what our answer is. When x is negative 4, we plug in negative 4. When x is 0, we plug in 0. Well, this is exactly what we were just talking about. The numbers that we're plugging in, the x's, represent the domain. The answers we're getting represent the range. In notation, it looks like this. We call our function by some name, in this case f. The parentheses beside the f say the variable is x. And so we see this notation a lot in mathematics. F parentheses x. That means we have a function whose name is f, and the variable is x. It has nothing to do with multiplication. And so here's the calculations that we just did. Here's a function, but we've drawn the graph of it. F parentheses negative 5 means what's the answer you get when you choose negative 5 for x. Well, here you see I've put a green arrow from negative 5. We go down to the function and look to the right to see what the answer is. So the x is the domain and the y is the range. F4. What answer do we get for 4? F5. What answer do we get for 5? This is asking, okay, what value of x gives an answer of 6? Well, here's the 6. Here's the x that gives an answer of 6. However, to find the domain of a function, we have three situations that we want to consider. Polynomials are things like this, and the domain of all such things is all real numbers, negative infinity to infinity. Rational functions are fractions where we have x's on bottom, and the main idea about fractions is you cannot have a 0 on bottom because there's no such thing as dividing by 0. So we want to know for each of those fractions what would make the bottom a 0. In the first one, as you can see, x minus 4 means x can't be a 4. Second one, x cannot be 3/2. And the third one, there's two numbers that x cannot be. Radicals mean square roots. And the idea here is you can't do the square root of a negative number. So we want the thing inside the radical to be positive or 0, greater than or equal to 0. Now those are the three situations that we need to know now. We'll add to those in the future.